Every decision carries consequences. Some you can see, others remain hidden until it's too late. In today's data-rich environment, the challenge isn't information, it's insight. What if every decision you made was backed by the power to see its impact before implementation? This is the power of Simio's intelligent digital twin technology. Our object-based, data-driven simulation platform creates a dynamic replica of your entire operation, continuously updated with real-time data from your systems. When you need to make critical decisions, Simio lets you simulate every possibility, change resources, adjust schedules, modify processes, see the results instantly. Our predictive analytics engine doesn't just show what might happen, it reveals potential risks and recommends optimal solutions. From reducing costs in manufacturing to optimizing patient flow in healthcare, Simio transforms complex data into clear direction. As technology evolves, so does Simio. Our commitment to innovation ensures you'll always stay ahead of what's next. Don't just hope for the best, know what's coming. Simio. Simulate what if with an intelligent digital twin. Visit simio.com today to discover how our digital twin technology can transform your operation from reactive to proactive, from uncertain to confident.
Greetings and welcome to the Simio Solutions Series 2025, last edition for 2025. Today's session is Accelerate Experimentation with Bypass. This is a Simio 19 Solution Series deep dive. My name is Dan Vasilini. I'm the Vice President of Global Sales. But doing most of the presenting today is going to be Jeff Smith. He is the VP of our training and academic programs. Our emails are shown here on the screen. In case you have a question today that does not get answered during the session, you can feel free to reach out to one of us directly. But hopefully we'll get to any questions that come up during today's session. A few housekeeping items before we get started. Just be aware that today's session is being recorded for replay purposes. As we've recorded every one of these Simio Solutions series in the past, the session is recorded. We put it up on our website after it's done. Usually we have it published within about 24 hours after the session ends. You can view this session and any session that we've done in the past simply by going to the simio.com. Under the Learning tab, you will see a Simio web series. And under that Simio web series, you can deep dive or dig into the solution series. We have 30 plus recordings that are out there. These have been going on for quite some time. Feel free to go out and watch any of these. If you have a question during today's session, because you are muted, there is a Slido polling area. Should be in your WebEx attendee panel on the right side of your screen. If you accidentally close that Slido polling area, you can reopen the app and it'll pop back up open for you. Type your question in there and we will ask the question. Generally, we will ask the question at the end of the session. Jeff's session is scheduled to last about 45 minutes today, so we should have time at the end for questions. As I mentioned earlier, this is the last session for 2025. We will be back in 2026. We're always looking for ideas and suggestions on potential future sessions. At the end of today's webcast, you will have a poll that pops up. We're always looking for feedback, as I said, on both today's session and any future topics that you might want to see. So feel free to, at the end of the session, please wait around as you close out your session. The poll will pop up and you can fill out some answers there for us. So thanks for attending today. We appreciate it. As I said, last one for 2025. Jeff, the floor is yours.
Thanks, Dan. As Dan said, I'm Jeff Smith, and I run the training and academic programs team. I'm happy to discuss our new bypass-driven experiment add-in. You can see my email address here, so if you have any questions about today's presentations, or if you want to discuss anything academic or training related at Simio, just shoot me a quick note. In this talk, I'll introduce the two new bypass-driven experiment add-ins and discuss how these add-ins fit into the Simio experimentation and optimization framework. I'll also demonstrate the use of these two new add-ins using an example model. Note that the example model, we used the same example model in a previous solutions talk from November of last year. You can see the link to the website here if you want to go back and watch that video recording. This is the example model that we'll use, and it's a resource allocation model. So you can see that I have a serial line And the decisions that I'm making are selecting the buffer size here, here, and here, and then the machine capacities. We also have a physical space constraint, and we want to maximize the profit. So this is a very common type of problem. Note also that I made up all of the numbers. So the focus here is on the methodology, not the specific optimization numbers. In the previous solutions talk, we talked a lot about how we build this model to support the optimization. We're not going to do that here. What we will focus on is just the idea that we are setting the reference properties and then using the output statistic to observe the profit values. So our assumption here is that I design an experiment where I set values for the reference properties. When I run the simulation, each replication gives me an observation of the profit from that configuration. And so the goal is to determine the reference property configuration that optimizes the profit. So here's the original model. So I'll just click run and you can see that we have the entities arriving. We have our reference properties here for our buffer capacity and machine capacity. And we have an experiment where we set the values for those 7 reference properties, and then we observe our 2 responses. The profit is the one that we're particularly interested in here. So once again, our goal is to determine the set of reference property values that maximize the profit value. Before we talk about bypass, I want to talk a little bit about the Simio optimization framework. This is a set of tools and methodologies that facilitates identification of good scenarios for a Simio model. Ideally, we'd like optimal solutions, but generally we can't guarantee that optimality. And our experimentation optimization framework includes 3 basic types of components. We have the results and data presentation, the tools, and the experiment add-ins. So I'm going to switch to Simio and talk about or just illustrate these results and data presentations. Let me pull up my Simio model, and you can see my experiment here. Well, the first component are SMOR plots, or response results. And you can see that this is a visual representation of the sample mean, percentile values, and the corresponding confidence intervals. We have the pivot grid, which is Simio's standard numerical results, and this shows basically all of the results from each one of our scenarios, and it supports named views, filtering, sorting, and so on. We also support reports, and with Simio reports, you can customize the report output and get the input in any basic format that you'd like. And finally, we have dashboard reports. Dashboard reports are custom designed dashboards that put you in control of the display of the experimental results data. Note also that the dashboards can be shared between models by using the import-export feature. What we see here is a just standard dashboard that shows information about server utilization, the stations, the input and processing and output buffer for the stations, and entities. And so note that we have a tabbed interface and we can show the data both numerically and graphically. And so if you'd like more information about experiment dashboards, see the Simio Help and Simio University, which is our online training platform. Where the results and data presentation components focus on displaying experimental result information to the user, the tools actually do something. And we'll see both of these in action, but in short, the scenario generator generates scenarios for your experiment, and the subset selection applies a statistical difference test on experiment responses based on the replication data. Our focus of this solution series is on our 2 new experimental add-ins, reject scenarios with bypass and select the best scenario with bypass. But we also have additional experiment add-ins as part of our optimization framework. We have the 2 select best scenario add-ins. First one uses KN, second one uses GSP. And finally, we have the OptQuest add-in, which implements the commercial optimization package OptQuest. We also discussed these existing add-ins, not the bypass, but the other ones, in the previous solution series talk that I referenced at the beginning of this talk. The scenario generator is an experimentation tool that creates scenarios based on values that you provide for the experimental controls. So for this presentation, I picked a really small experiment because I'm running this all on my laptop. And you can see what I want is I want to look at scenarios where I have either 6 or 7 buffer slots on one, 7 or 8 on two, 1 or 2 on 3, and so on. And what I'd like to do is a complete enumeration of all possible scenarios here. And so you can see that there are 864 possible scenarios because I have 2 times 2 times 2 times 3 times 4 times 3 times 3, which is 864. But as I mentioned earlier, we have a space constraint where the sum of A, B, C, and D have to be less than or equal to 15. So once we apply that, as we'll see, we have 432 of the 864 scenarios that meet that constraint. And so creating these by hand would be difficult, or arduous actually, not that difficult, but using the scenario generator, it's quite easy. So let me just pull that up and let's have a quick look. So here's my model, and you can see that I have my controls here, I have my responses here, and here's my constraint that I mentioned before. So there's my capacity constraint that you can see. You have to have at least one of each one. Well, it just actually the constraint is that the sum has to be greater than or equal to 4, and the upper bound is 15. So when I open the scenario generator, you can see that I have this pre-configured as I showed in the PowerPoint. And so I can expand each one, and I give for each one of the controls that I want to include, I just say, yes, I want to include it. I give a minimum and a maximum and the number of levels. In our case, as I said, I wanted a complete enumeration. So we have 6 and 7 in 2 levels, so that will give us 6 and 7. 7 and 8, 2 levels will give us 7 and 8. Jump down to one of these, like this one, capacity B. I have a minimum of 7 and a maximum of 10, and I want 4 levels, so that's going to be 7, 8, 9, and 10. You can also see that it computed the maximum number of scenarios. Of course, the constraints don't apply. It doesn't know how in advance to apply those constraints in that calculation. So it just gives you that maximum. And so when I want to generate those, I just click that button, and you see here that we generated the 432 scenarios. So the scenario generator is an extremely useful tool for creating scenarios based on an experimental design. And finally, we wanted to generate a complete enumeration, but I don't have to do that. So for example, if I'd had a minimum of 2 and a maximum of 6 with 2 levels, that would just be a 2 and a 6. If I say 3 levels, it would be 2 and 4 and 6. So you don't have to completely enumerate. You can determine what the levels that you want for each factor. In our example model, all of our controls are integer. So the buffers, machine capacities are all integers. With the scenario generator, however, you can also generate scenarios over real values and list values. With a real value, for example, I could have the minimum of 0, the maximum of 1 with 3 levels, and I would get 0, 0.5, and 1. If I have 0 and 1 with 5 levels, I would get 0, 0.25, 0.5, 0.75, and 1, and so on. And with a list variable, or with a list control, then it will just enumerate over all values for that list. Our second tool, subset selection, helps us determine when better is actually better. So let's have a look at this experiment where I have 4 scenarios, and our goal is to maximize profit. And if we look at the values in the profit column, we see that scenario 3 has the highest profit value. However, we also know that these are point estimates based on the replications. So I ran 10 replications of each scenario, and the profit that's shown here is the numerical average. And so there's some statistical sampling error associated with that. And so what the subset selection does is identifies the statistically significant difference, and it divides the set into two groups for each one of our responses, the potentially best group and the rejects. So in this case, what this is telling me is scenario 3 and 4 are statistically higher than the set 5, 2, and 1, but there's no statistical difference between 3 and 4. Note that that doesn't mean there is not a difference. It just means that we haven't run enough replications to detect a difference if there is one. Subset selection is an extremely useful tool, but there are two basic issues with that. First is multiplicity. It uses pairwise comparison, so the more scenarios you have, the more complex or the more computationally intensive it is, also the more conservative it is. And secondly, it's a one-shot test. So I've applied subset selection here, and if I want to continue experimentation, like let's say I wanted to increase the number of replications and see if one of these will eventually stand out, I have to replicate the entire thing. So I can't just focus on those that were in the potentially best group without reducing the statistical significance of the test. Now that we have the background out of the way, what exactly is BiPASS? Well, BiPASS stands for Bisection Parallel Adaptive Survivor Selection, and it's a ranking and selection procedure developed by Linda Pei, Barry Nelson, and Susan Hunter. I provided two references for you that have complete details about the theory and the implementation of BiPASS. And in our talk, what we'll focus on is a very high-level description of how the process works, and then more detail in how to use Simio's implementation in our two experimentation add-ins. BiPASS is designed for parallel processing and works well with large numbers of scenarios and processors. So it uses a master worker structure where the master process accumulates results and makes elimination decisions, and the worker processes each execute replications. And so you can fully utilize all processors or cores available. So this is the basic idea of BiPASS. I'm going to run all case scenarios for some small number of replications. In Simio's implementation, that minimum value is 6. And from those 6 replications of each scenario, it estimates the variances. From there, it's going to eliminate the uncompetitive scenarios. And it eliminates those uncompetitive scenarios in a way that explicitly controls the expected false elimination rate. Then it's going to run an additional replication of each remaining scenario, and then again eliminate the uncompetitive scenarios, and then decide if you want to continue. So you go through this sequence of running a replication, eliminating, running, eliminating, running, eliminating, until you decide to stop. And two very important points here. One is that the uncompetitive, the criteria for eliminating scenarios is adaptive. So as we collect more information by running more replications, we adapt the elimination criteria. And secondly, because we focus on eliminating non-competitive scenarios rather than keeping attractive scenarios, we can stop and restart the procedure. So if I run for some number of replications and I decide to stop, I can restart the process without rerunning the existing replications. So that's the basic idea of BiPASS. Let's have a look at Simio's two BiPASS-driven experimentation add-ins. The first one is called Reject Scenarios with BiPASS, and I'm going to open Simio and show how to get that started, and then we'll look at a finished run. And so this is where we use Scenario Generator earlier in the presentation, and I generated our 432 scenarios. In order to use our add-in, I'm going to go select add-in, and here are the two that are BiPASS related, and I'm going to do the first one, Reject Scenarios with BiPASS. And you can see that it added another section in the experiment properties. And the first is a confidence level. The second is the initial number of replications. So as I mentioned in the basic procedure, this is the initial number of replications that all scenarios will be run for to do the initial calculations. I also specify the maximum number of replications I want the add-in to run. I can give a lower bound, so the lower bound can reduce the number of scenarios that are tested. If you leave this at minus infinity, it's not going to use the lower bound calculation. And finally, you can specify whether it's single objective or multi-objective weighted. If it's multi-objective weighted, then it's going to look at the weight associated with each one of our responses. Otherwise, if it's single, which mine is here, then it's going to use the default, the primary response, which is, in our case, is profit. So once I have the scenario set up, I can simply hit run and the experimentation starts. So you can see that we're running the scenarios, individual replications of the scenarios, and getting the feedback that we typically do with Simio. And so the number of replications that run simultaneously will depend on the number of processors or cores that you have. And so it's pretty boring to watch, so I'm going to stop the video and then come back once it finishes. So here's the completed run, and you can see that I still have 1, 2, 3, 4, 5, 6, 7, 8 scenarios selected. And if you look, all of those 8 scenarios ran for 50 replications. And so our 50 replication, let me show the experiment properties here. This is where our maximum replication count came into play. So we still had 8 competitive scenarios, but we ran up until that maximum. If we scroll down to the bottom, you can see the basic behavior of bypass, and that we have a whole lot of scenarios that only ran 6. So these are the scenarios that were eliminated in that first pass after running those priming runs. Then I have another whole set of scenarios that were eliminated after the 7th replication, and then some after the 8th replication, and so on. And so the basic idea of bypass is that you start with a large number of scenarios, and it quickly eliminates non-competitive scenarios. And so by quickly eliminating those non-competitive scenarios, it lets you look at a large number of scenarios and cover a larger portion of the solution space. So now that the add-in's terminated and I have my 8 scenarios left, I have several options here. One option can be I can just stop and say that these are equivalent. So in terms of our profit maximization criteria, these 8 scenarios are equivalent. Note that when I say equivalent, I mean that they're statistically equivalent. And so they're close enough in performance that bypass can't separate them based on this run. So they may be different, but we would need to run more replications in order to detect the difference if it exists. If I want to continue experimentation to try to find the one that is the best, if there is one, I could increase the maximum number of replications. So I could go in and say, okay, well, let's make that 60. And because of how bypass is implemented, as I said, it's restartable. So I don't have to go back and rerun anything. I can just start it right now. And you can see what it's going to do is just run run the additional 10 replications for our 8 selected scenarios. And then after each replication, it's going to go through this elimination phase. So I could do that. I could continue doing that until either I'm ready to stop or it identifies one. But I will note that the way bypass is structured, its focus is on quickly eliminating non-competitive scenarios rather than on quickly identifying the singular best if it does exist. So it can slow down. The process will slow down as you run more replications and get a smaller number. Another option is I could use one of our other add-ins. So I could go in and say, I want to use on my 8 scenarios, the select best scenario using good selection procedure or KN. I could do either one of those. But instead, what I'm going to illustrate is how we use our second bypass-driven experiment add-in, and that's select best with bypass. This add-in incorporates 2 procedures. We start with bypass exactly like we did with the reject scenarios method, and then at some point in the process we switch to a second procedure that's similar to our select best with KN or select best with GSP, where what it does is it takes the selected scenarios and it tries to identify the singular best. And so it will either stop when it reaches the maximum number of replications that you give it, or it identifies that singular best. And in order to do that, we also have to incorporate the notion of an indifference zone. And so an indifference zone is the minimum amount of the objective function value, in our case profit, that I want to identify 2 scenarios as different. So for example, I have an indifference zone of 25, which means if I have 2 scenarios that are within $25 of each other, then they're viewed by the procedure as equally good. So back to Simio, where we left our previous add-in, reject, and we stopped at 50 replications, and then we increased that to 60. One of the options that I mentioned was to use one of our other add-ins, the select best add-ins, with the remaining 8 scenarios. Well, the select best with bypass essentially does that in a single step. It uses the bypass process, and then it uses a switchover procedure, which I'll discuss in just a little bit, to switch over to a different procedure, which is more focused at taking a smaller number of scenarios and identifying the unique best if it exists. And so let me just jump to there because it's pretty boring to watch. So let me just jump to that select best with bypass where it's already run. And so I ran that. Note that I have 60 for my maximum number of replications. I'm sorry, there we are, select with bypass. Notice I have 1,000 as my maximum number of replications because I know that it's going to switch processes at some point. So it's going to not run all of the scenarios for 1,000. It's going to run a relatively small number for that 1,000. And I have my indifference zone of 25. And if I scroll to the top, what we notice is we do have a single scenario highlighted. And if we look at our 8 scenarios that we had before, you can see that the switchover happened. In our case, the switchover happened after the 41st replication. So there were the 1, 2, 3, 4, 5, 6, 7, 8 plus these two, which ran for 41 replications. And then the add-in said, I'm switching to the new process. And so now with those remaining 8, you can see that they all ran for a different number of replications. So that's indicative of the other 2 select best procedures that we have, that part of the procedure decides how many replications of each scenario need to be run before I either reach the maximum or can identify the singular best. And so you can see that's exactly what happened here, is that I ran 163 for this one, 265, 202, and so on. And let me reiterate that the process itself calculates these values. That's not something that we input as part of the parameters. So to recap, our reject scenarios with bypass add-in implements the bypass procedure using an initial number of replications that you give it and a maximum number. And so it's going to run for 6 replications, eliminate the non-competitive scenarios, then run a 7th, eliminate an 8th, eliminate a 9th, eliminate, until it either gets to 50 or until there's a single scenario left. In our case, it terminated at 50 with 8 scenarios left. The select best with bypass starts with that process, and then at some point, which I'm going to talk about here in just a second, it switches over to a select best procedure where it takes the identified scenarios and runs those until either it identifies a unique best or until it gets the maximum number of replications. And of course, we also, in this case, had to incorporate an indifference zone. In this chart, I tried to capture what happens as bypass runs. And so you see on the x-axis here, I have the replications, and on the y-axis, I have the scenarios. And I'm plotting 3 things. The blue line is the numbers of scenarios that are eliminated at the end of a given replication. The orange line is the cumulative number of scenarios that have been rejected, and the gray line is the number of scenarios remaining. And so recall that we started the process with 432, and so that's represented right here. You can see I have a 5 here, so this is just before the first elimination phase at the 6th scenario, at the 6th replication. And we ended with 8. And so you see that 8 here at the end, at the 50th scenario. And so you can see a couple of things. First of all, remember that the idea of bypass is that we quickly eliminate non-competitive solutions, non-competitive scenarios. So you can see that we've gone from 432 to just a little over 100 in 9 replications. And so we have a really quick drop off, and then we still drop a little bit, but our pace of elimination has slowed down a bit. And then out here around 41, you can see that we stopped eliminating scenarios completely. So the 41st scenario to the 50th scenario, it doesn't look like we eliminated any. And then the reject add-in terminated here with our maximum number of 50. For the select best with bypass add-in, remember that there's a switchover. So we start out with the traditional bypass, just like you see here, and then at some point we switched over to a select best procedure. And so we don't see exactly where that happened here, but if we go back to our if we go back to our results, we talked about the fact that it happens right here after the 41st replication. So after the 41st replication, at some point, it stopped. Well, if we look at our plot, I can describe exactly how that happens, and then that will hopefully make a little bit more sense. So right here at 41, we didn't see any changes. One of the criteria for the switchover is if we ran 15 replications without eliminating in any scenarios. And so that's exactly what happened here. As we started out at 41, we ran an additional 15 replications up to, what would that be, 56. No scenarios were eliminated, so we then switched over to the secondary procedure. And so in the secondary procedure, that's where, well, let me pull that up here. Yeah, in that secondary procedure, this happens here. So it didn't happen here at 41, but it happened at 41 plus the 15 scenarios where 15 replications where no scenarios were rejected. So going back to our plot, you can see that that switchover would have happened somewhere right around here, because this only goes up to 50 because this is a plot of our first add-in performance, but somewhere around right here at 56, that switchover would have happened. There are two other criteria that can cause a switchover to happen also. At each stage, the add-in tries to estimate how many replications are required for the select best procedure, along with how many replications would be required to continue bypass. And if fewer replications are estimated for the select best, it switches over immediately. And the final criteria is if there are 0 replications estimated for the select best, meaning that if you use the select best procedure, you can immediately declare the single scenario the best, it will switch over and then declare that scenario the best. And while that might seem like a strange criteria, in other words, why would the select best be able to immediately terminate while reject with bypass can't? It's because of this indifference zone. Once we move to select best, we're incorporating an indifference zone, and the reject scenarios does not have an indifference zone. So it's continuing to look for the singular best. So before we added the bypass add-ins, our standard process for finding the best model configuration was as follows. We would build the optimization-friendly model, like we have, again, with reference properties for the decision variables and experiment responses for the objective function. Then we would identify a set of potentially good scenarios, and we can do that manually. We could use OptQuest to do that, or we could use the scenario generator. And then we would run those and use subset selection to identify the set of potentially best from that set. From there, we could either stop or we could use one of the select best scenario add-ins to identify the best. With the bypass driven add-ins, we can update that, or we can actually augment that by saying we can identify a large set of potentially good scenarios using scenario generator. That's the easiest way to do this large set. And then we can use the select best scenario using bypass to identify that singular best scenario. And so this is ideal for computing environments with lots of cores and processors, and what that lets you do is explicitly consider a large portion of the solution space. And to see why that's important, let's look at an abstract view of two different optimization problems. So what we have is a two-dimensional optimization. So X and Y are our decision variables, and then the Z-axis is our objective. And note that this is 2 dimensions, but the problem that we're solving in Simio is 7 dimensions, and so we can't visualize that, but the concepts are the exact same. And so when we look at the one on the left, we have a nice, well-formed objective function. And so basically, if I can explore any of the regions around this optimal, around this red region, then I can easily find the best one. But if I look at the one on the right, it's not quite so well formed. In addition to our global maximum, we have several different local maximum. So if I'm right here, for example, then I might get to this point and say, look, I am at the best because I look all around my area and I can't see any better solutions, right? And so what I need to be able to do is explore more of the region. So rather than just focusing on the best one that I find, I need to explore more to make sure that I'm not at one of these local maximum. So again, this is a concept. In practice, we have no idea what our objective function, what the contours of our objective function look like. We don't know that. And so we have to assume that it would be better, it would be more likely to find the true best solution if we can explore more of the solution space. And by incorporating the process that lets us do that, by exploiting parallel processing and then quickly eliminating the bad solutions so that we can focus on the potentially good ones, which might be, say, this one and this one and this one and this one and this one, then we can have a better opportunity to identify this truly best solution than if we just explored a region around, say, one of these local optimum. So now the question becomes, I need to find the best scenario. What should I do? Well, unfortunately, there's no general answer, but the things to keep in mind are the following. First of all, do I really need to find, quote, the best? So if I go back to our model, the model that we solved here, and if I just go back to the reject with bypass, recall that we stopped here with 8 scenarios. And if we look at these scenarios closely, we see that the capacity, so remember that the problem that we're solving is machine capacities, A, B, C, D, and buffer capacities. And so if I look at my solutions, all of these solutions that were identified have the exact same machine configuration. I'm going to have 3 of A, 8 of B, 2 of C, and 2 of D. And the only thing that differs is that buffer configuration. And if you look at the differences in those buffer configurations, they don't really differ that much. So the question would be, do I really need to go any further, or can I just stop with any one of these and say, let's look at another criterion for choosing what I'm going to do? And that relates to the second condition also is, well, how confident am I the metrics that my model computes? So in our model, we're optimizing, or we're maximizing profit. So the question is, is this an accurate measure of profit, right? Because it doesn't make sense to spend an enormous amount of time finding an exact best solution if the criteria that I'm using is not equally precise. And so we might just stop right here, as I said before. And then finally, the last consideration here is, well, what's my compute environment? If I have a big computer, lots of processors, I might as well explore a whole bunch of the space, right? There's essentially no cost to doing that extra exploration, and so we can essentially get that best solution at no additional cost, and we haven't really lost anything. So in summary, the addition of the 2 bypass-driven add-ins significantly expands the capabilities of the experimentation optimization framework. And because simulation experimentation projects can vary tremendously from project to project, it's important to have this comprehensive set of tools and techniques at your disposal. And finally, with respect to the framework, we didn't even discuss the ability for users to create their own custom experimentation add-ins. But that's a topic for a future solutions presentations or Simio University course. And so at this point, I'll be happy to answer any questions from the audience.
All right, Jeff. Great, thank you. All right, let's get the first question up here. Can the controls and ranges for the scenario generator be imported from either a Simio table or an external file?
Unfortunately not. In its current state, the user interface for the scenario generator is the one that I demonstrated. That would certainly be a good feature request, though, to make that process a bit easier. But for now, it's just use the dialog box.
All right, as you said, though, I'll add that to the list here, and we can add it for futures. All right, next question. How do I decide which of the 2 bypass add-ins I should use in an experiment?
So the reject scenarios simply runs through the bypass procedure until you reach either the maximum number or until it decides there's a single best, whereas the second one, select best, will then do that secondary procedure where you're sort of adding on a select best procedure. And so the most, I would say, hands-off way to do that is to use the select best, because in one shot If you want to specify that indifferent zone, you can do both. If you want to get a feel for the problem, in other words, if you want to see what the competitive scenarios look like, for example, then you could always do a shorter bypass run and then just see how that ends up. So that would be a faster process. It just doesn't generally lead to that single best. So it really kind of depends on what your goal is.
Okay, perfect. All right, next question. There are now 3 add-ins that select the best. What bypass, KN, and GSP? What are the main differences between these, and how do I know which one to use?
So the previous two, before we introduced bypass, in our last public release, we had select best with KN and select best with GSP. And so those 2 add-ins are targeted at the exact same thing, to take a relatively small number of scenarios and identify the singular best statistically if it exists. The differences between KN and GSP really are internally how it executes, but the rule of thumb that I generally use is for a smaller number of scenarios, I generally use KN, for a larger number, GSP. Bypass now introduces this initial procedure. If you do the select best with bypass, then we're getting that initial bypass run to get rid of the uncompetitive scenarios early. And so what that lets you do relative to the select best with KN and select best with GSP is start with a larger number of scenarios. So I can start with a much larger number of scenarios that covers more of the solution space, rely on bypass to quickly eliminate the non-competitive ones, and then switch over to the select best procedure to do that secondary part.
Okay. All right, looks like we've got 1 or 2 more questions here. Next one. What differentiates bypass from OptQuest, and when would you use one versus the other? And I know you could probably do a whole separate webcast on this question by itself, but in 5,000 words or less, let's go.
5,000 words. That's a pretty good budget there, Dan. Thank you.
Exactly.
So bypass, the short answer is bypass is a ranking and selection procedure. And so essentially you tell it the scenarios, and then it tries to identify the statistically best or statistically set of the best scenarios. Whereas OptQuest is a heuristic optimization tool where you don't tell it the specific scenarios, it generates those scenarios based on a set of heuristic procedures. And so in terms of when you use one versus the other, what bypass will generally do is let you be in control of what you're exploring. So if you use bypass in conjunction with the scenario generator, you tell it exactly what you want to cover. And so in the case like the example that I showed in the session, all of our controls are discrete. So I could say, look at every possible solution, or look at every possible scenario. And so by doing that, what I end up with is the guaranteed best, again, in a statistical sense. Whereas with OptQuest, I don't have to pre-specify that, but I also don't end up with the guaranteed best. I might end up with the best, but you won't know it because of the way the heuristic works. And so, in general, as part of the general toolkit, I think both of these tools are valuable. Bypass, again, you're in more control over what you're exploring, but OptQuest is quick and easy and generally does a good job. The key there is that you just don't know in advance. In the slide where I showed the 2 solution spaces where you had the unimodal and the multimodal solution spaces, you just don't know what your solutions profile looks like. And so a safer bet for finding the best is covering more of the space. A quicker bet would be to use something like OptQuest.
Okay. Yeah, that was definitely less than 5,000 words, Jeff. So I appreciate it. All right, I think there is. I think that's it when it comes to the questions. Let me just check one last time. Yeah, that's it from the question standpoint. So look at that. We are right at 45 minutes. At the beginning, I said your presentation would take about 45 minutes, and I didn't include the questions, but we're finishing right on time. So as I mentioned at the beginning, thank everyone for attending. Thanks for being here in 2025. with it being December and a holiday month for a lot of people coming up. We will not be doing one in December, as I mentioned earlier. We will be back next year. More than likely, it'll be February. January is also kind of one of those months we usually skip, but we may make a special announcement that we're coming in January. So be on the lookout. You'll see the email from Simio as soon as we have our plan for next year. Also, as I mentioned, when you exit today's webcast, you will have a survey pop up. Please complete that survey. Give us any suggestions for future webcasts, any topics you might like to see, and we will be happy to accommodate, as we're always looking for ideas. So once again, thanks everyone for attending in both this webcast and in 2025. If you're watching this webcast on recording, thank you for watching the recording. There's plenty more out there to watch, and we will see everyone next year. Goodbye.